Hi, I'm Woo-Young Chung. I'm a track producer for this session, and I'm delighted that you decide to join us for this session. See, data lake has been a quite important topic in our field for a long time. Now, um, in this session, two distinguished speakers will be discussing massive scale data lake. Without further ado, I hand it over to Aaron.
Thank you, Woo. This is Aaron Carreras. I'm Vice President of Data Management and Transparency Services Technology at FINRA. And joining me is Nate Weisz, who is the Senior Director of Data Management at FINRA. And we'll be talking to you about building and managing our 200 petabyte. All right, first a little bit about FINRA. FINRA is dedicated to investor protection and market integrity. We monitor and regulate 3,700 securities firms by deterring misconduct through enforcing rules, detecting and preventing wrongdoing in the US markets, and disciplining those who break those rules. In support of that mission, FINRA processes up to 445 billion market events per day. We oversee 24 exchanges, 630,000 brokers, looking for fraud, abuse, and insider trading. We collect that data, not and process it daily, but we also keep it and store it for further analysis. So that data lake grows every day. And at this point today, it's well over 200 petabytes of storage. And we run 150,000 compute nodes per day to do all the processing, which we'll get into a little bit further. In order to be successful at such an endeavor, obviously a key is the people. And FINRA recently was voted #1 best place to work for mid-sized companies again in 2021, just as they were in 2020. Next slide, Nate. So a little bit of background in terms of where we were before we've got to the current state of our data lake. We started on-prem. We were at one point on traditional relational databases such as Oracle. We outgrew those and moved into data appliances. But we were experiencing rapid data growth, 20 to 30% year over year. And we were finding that it was very difficult to build for peak or costly. We constantly had to reassess where the market was going, and if we knew where the market was going, we might be doing something different. So it was really challenging. You had to be ready for those spikes in days, and ultimately we would end up we'd outgrow the hardware we have, and the choices were either buy additional hardware or try and scale up, and it was taking away from our ability to support our core mission. Day to day, we'd have various analytics needs, whether it was regulatory response requests or whether it was our own analysis to figure out how to better protect the markets. In support of that, we would oftentimes find ourselves shuffling data between different analytics platforms, and which exacerbated the challenges around data governance, keeping track of where the data was, figuring out which data could be moved to a different storage to allow a certain amount of performance to complete jobs we needed done. Retention was also a challenge. And how do we manage that data at scale? How do you experiment? How do you try new capabilities when the processing and the storage were co-located and they were so valuable getting our day-to-day work done? Next slide, Nate. So when we decided it was time for us to take a different path, to us, the choice was obvious. We needed to move to the cloud. And so we settled on putting all of our data into S3. It was one location, scalable, durable, performant, and cost-effective. It also allowed us to do something we thought was absolutely critical as we evolved, and that was to separate our storage from compute. We wanted the ability to run transient nodes, have elastic compute, pay mark-to-market pricing, be engine agnostic, and evolve the ecosystem as we saw new technologies evolving without impacting our production systems. Separating that storage from compute allows us to try new things with new software on new hardware without impacting our day-to-day processing. Next slide, Nate. So this is a high-level overview of what our FINRA data lake looks like today. This includes components not just of the catalog that we depend so much on, but also kind of how we see processing at FINRA. We start with ingestion, and that is made up primarily of machine-to-machine intake, but we also have web apps, web forms to bring in financial filings and things along those lines from our member firms and elsewhere. And then whether it be coming in through a manual effort or through a machine-to-machine interface, it goes through a processing to validate the data, transform, enrich, and link the data. And then our business users oftentimes have some problem that they're trying to solve, and they need to figure out which data might be applicable, what data do we have available, and understand that data. And that's where our search and discovery universal data catalog, you'll see the UDC on the slide here. And then, of course, the thing that everyone's focused on these days, but has been around for a while, but is constantly evolving, is our analytics. We have ad hoc querying, which over time, we've started with Presto, did some Redshift, but have now largely on Presto, whether it be Athena or Starburst Presto or EMR Presto. We have the data science space, which we leverage multiple different options, primarily Spark, but a good bit of Python, some R as well. And then we have our batch analytics, which we rely on heavily for that processing. Underlying it all is that storage in the catalog that we rely so much on. It wasn't enough to just put the data in S3 and hope we could find it later. We rely heavily on that catalog to support many aspects of that data lifecycle. It keeps track of what we have, the data versions we have, the schema as appropriate, and it facilitates the workflow that many of these upper tier boxes you see rely so much upon. Most of the time, it's not, data doesn't come in and hit just one area here. There's a pipeline, and the workflow allows teams to depend on not just constantly polling where the data is, but also to get notifications upon new data coming in, when it was registered, and immediately act upon that data, scale their own processing needs, and then again register that data back into the catalog in S3 for continued processing. With that, I'll turn it over to Nate to give more details.
Okay, thanks, Aaron, for getting us to the big picture. I'm Nate Weisz at FINRA. I've been working with the team that is building and maintaining this catalog since I got here at FINRA, so I've had kind of a front row seat to everything that goes on in the data lake. And but it is, like Aaron says, the work of so many people that we're happy to be able to present here today. So I'll start by drilling in and zooming in on our batch surveillance. And that's where we look for patterns of wrongdoing across these massive amounts of data. Historically, it's been run by SQL on big data appliances, and then it moved to SQL on Hive, and then more recently, it's moving to Spark SQL and mixing in some Scala and Python and machine language. But the way we moved from data lake V1, V2 here highlights one of the points Aaron was making, the key advantage of separating storage from compute. So if you look back to, for example, when we migrated from a commercial relational database to a big data appliance, that was a traditional data migration, like I'm sure many of you in the audience are familiar with. It's a very complex, delicate, and time-consuming effort to migrate a system and data like that. But if you look at how we migrated from Hive to Spark, for example, it's different because the storage and the computer separated. The storage just stayed untouched in S3 the whole time. And we could start with a kind of a lightweight experiment where we would take one workload and move that from Hive to Spark, and it could be done, without nearly as much effort. And it didn't have to be a big bang either. There was no before the migration and then make sure that all of your ETL is ready for it and then go after the migration. Could be done in a lot more low risk and agile fashion. The last point I wanted to make here is to move in that agile fashion and to migrate. It also took us taking a step up in our automated testing, our functional and regression testing, to make sure that we could move that workload or that set of workloads without breaking it. That's a recurring theme you'll see here again and again. If we're moving in an agile fashion, we need to rely on that degree of automation, production testing, and things like that. So the next thing I'm going to talk about is the metadata. I'm just going to take a moment to turn my mic up so everybody can hear me better. Sorry, I can't do two things at once. There we go. I hope that's a little louder. And the metadata is an area where in the beginning, our focus was on the physical metadata, everything required for the teams to do the processing and analysis that's so important to our data lake. So that means, when a team brought data into the data lake, they're writing software, that software registers it in the catalog. It registers the format, the columns, the data types, the S3 location, everything that a consumer of that data needs to do to use the data. After focusing on that for the first year and a half or 2 years of the data lake, we realized we're sitting on a gold mine of metadata, and that we wanted to get more and more value out of what's in our data lake and help the human beings who are going to be kind of at the front end of the forefront of all of our analysis work, the data scientists, the analysts. So we built a layer of business metadata, and our mantra at that point became everything required to search, discover, and understand the data that's out there. So we added descriptive information, column level descriptions, business friendly table names and column names. We indexed that and made it searchable and available in a UI. You see here on the screen. So there have been some challenges there getting our business metadata populated with good coverage and maintaining it over time. We started with kind of a brute force effort where we had data analysts on our teams try to populate kind of a critical mass. But people didn't really pick it up and maintain it as much as we hoped. So we've been working with the friendly teams who are good at it, and we're really starting now to formalize the role of a data steward to take that responsibility. So here in the data lake, maybe more so in the warehouse, because the data lake is famous for easy to publish into, put in whatever format, raw data, process data, but the risk is it becomes a Wild West or a data swamp. And I think what gets you out of this is good metadata and good governance, but it all starts with good metadata. Okay, now I'll present a series of slides where we show some stats and then go into the story behind the stats. The first slice we're going to look at is the data volume. So here, the stat we look at is the number of market events per day. A market event is everything that makes up a complex order lifecycle, the quotes and orders and routing and cancel and trades in the equities and options markets. So we measure that here, and we see that on an average day, we're getting around 200 or 300 billion of those events in every day. It wasn't that long ago that this was 75 billion was our peak, 135. Now on the peak day, we've gotten up close to 450 billion events per day. So what's the story behind that? This is hundreds of terabytes of data per day. And what kind of process are we doing? Well, we validate that data. We do quality checks, normalize, enrich the data, transformation, link the data, everything we need to do to prepare it for batch analytics, then running batch analytics on it and making it available for interactive analytics. If you look at some other large-scale data lakes in the cloud in AWS where we are, I think you might see that they have lots of video, and they're encoding lots of video in different formats for streaming. That is certainly requires a lot of compute power. It's a lot of processing and storage. But here, what we're doing every day is more like traditional data operations. Our ETL is doing massive joins and transformations. Our batch analytics are doing massive scans and aggregations. So we're doing more traditional like data operations like many of you in the audience in our data lake analytics. And that's by and large these days powered by Spark and Presto. Central to how all this comes together is the concept of event notifications that Aaron mentioned, that workflow. So in this case, we might get some data in from the market, a slice of the market from one exchange or something, and that gets registered in the catalog through an automated process, which kicks off a notification. And then anybody, like a downstream job, maybe picks up that the first job might validate that data. So it's listening for that notification, validates the data, registers it in the catalog, notification goes out, kicks it off downstream, so on and so on. You know, there's a whole dance of this with several hundreds of interrelated jobs doing the ETL processing overnight. So that's a picture of the volume and the types of data processing. The next look is at how we use our manage our compute resources. And a quick answer to how we handle this volume is we simply provision more compute power as needed, you know, using the cloud. So here the purple graph shows, you know, on a peak day back in April, we're around 60,000 nodes. We recently reached a peak in May where we ran about 150,000 nodes in a day to accomplish this processing. There's a story behind this. And I think key point is something Aaron mentioned, and we use a lot of transient clusters. That's how we achieve this degree of elasticity and variability in our compute. And so that's several hundred clusters that come up, are spun up for one workload or a few similar workloads, and then they go away at the end. And each of those clusters is sized, or many of those clusters are sized variably according to the market volume. So say there's an ETL job doing a transformation. The upstream data is processed and arrives, a notification fires, the transformation job picks it up. The first thing it does, it looks at the upstream, looks at the number of rows, and adjusts the size of the cluster that's needed for the transformation job. So we have hundreds of clusters, you know, sized only for what is needed. Clusters are alive only for as long as they're needed. And that compares, you know, it's very, very different than pre-data lake, where we kind of scaled more by a traditional process of capacity planning. We tried to look forward and predict growth and peaks, and we provisioned hardware and stood it up in our data centers. And, you know, that's very different than how we're scaling today in a much more fluid, elastic fashion. The next cool part of this story is around cost. So in the beginning, our focus was on, you know, when we first built the data lake, stabilizing the pipelines and giving the basic analytics capabilities. But we started soon looking at the cost. We were running our clusters with what AWS calls on-demand pricing. That means I want a cluster of this shape and size. Cluster is given to me. I keep it for as long as I need. It's guaranteed to be there for as long as I need to run my workload. Then I'm done. AWS also offers their excess capacity on what's called the spot market. And that is at a fraction of the price, say like 30, 40, 50% of the price of the on-demand pricing. But the deal we make is if that compute cluster is needed for something else, AWS can take it away from you if you purchase it on the spot market. So we're an SLA-oriented shop. We're very oriented towards getting that data available for analytics as quickly as possible. And we have a lot of guarantees we make internally and externally. So there's resistance to using the spot market, which could involve a lot of unpredictable failures. But we started experimenting, testing, analyzing. And if you fast forward, this was a process that took months, but not years. The majority of our ETL and batch analytics were running on the spot market. And we had to get better at figuring out which jobs should stay on demand, which jobs could fail once or twice and then automatically go over to on demand. And we had to get better at making, you know, our jobs all fault tolerant, making sure that any job that failed at any part of the process could retry clean. And we relied again on our automated testing capability to do this. So taking a step back here at the cost, what really has happened is that the capacity is no longer the constraint. The cloud has given us the ability to, spin up as much compute as we want when we want it. So we've shifted and spend a lot of our time managing cost. And it's not only spot pricing, there's instant fleet capabilities, there's reserved instances. If we know we're going to use this many of this type of instances, we can pre-purchase them, for 6 months or a year in advance, get a significant cost saving. We also look at saving costs. The example I gave before about moving from Hive to Spark, well, we did that for performance so we could get jobs done quicker. But also, if a job completes quicker, a given workload takes less instance hours, that's less cost. So we're looking almost every angle on how to manage the cost of our compute usage. And the last dimension we'll look at here is storage. And we've grown here. This slice of the data lake we're showing has grown from 2025 to over 200 petabytes in this period. Of course, how did we scale this? We just wrote more data to S3. It didn't involve procuring hardware or buying expensive racks full of storage devices or anything. But there is still a cost associated with it. The S3 standard shown in these colors is about $22,000 per petabyte per month. Then there's an infrequent access, which a lot of our data goes into, and that is about half the price, $13,000 per petabyte per month. And then there's deep archive, which is 1/20th the price of standard, 1/13th the price of infrequent access. It's very inexpensive, but that's offline storage, and it requires requires a restore before you can read it. So what's the story behind these stats is, it's about, again, controlling cost, and we're doing that by using these different storage classes. We want as much as possible to get into this inexpensive Glacier deep archive storage. So what did that look like? Well, it was a no-brainer. We immediately put things like our logs and our database backups in deep archive. But the data in our data lake that's used for analytics, that was different. We have this team of 2 to 3 people, and part of their job, they're looking at the storage overall. Part of their job is to look at kind of cross-cutting concerns like cost. And they had to coordinate with the consumers of the data, the teams that are running batch analytics, the data scientists, the data analysts that are doing interactive analytics, and had to say, okay, just because we can now keep this data online forever, we don't have any capacity constraint anymore, we can keep it online. It doesn't mean we have to. Let's balance the cost here. How frequently does your analytics go back over 3 years for the given data sets or whatever? So we started having these discussions, and they had a lot of questions, little pushback. Well, how long does it take to get it restored, to get it back online? Is that going to be reliable? Is that going to cost a lot to restore the data? So we had to go through a process. We were able to test large restores, bring back several hundred terabytes, and reliably, in fact, much, much more reliably than tape. And so the long short of it is that we got to a negotiation with the different consumers, and they would agree at some point, okay, this set of data can go to Glacier Deep Archive after 3 years. So now we have many, many petabytes of data sitting in, of aged kind of analytics data sitting in there at a significant cost savings. We did need to step a little bit away from the tools that the cloud provider gives us. Those worked at sort of a gross level. Oh, the data in this S3 bucket can be moved to Deep Archive. We ended up putting that in our catalog because when we did these negotiations with the consumers, they had a lot of specifications. Well, these tables can go after 3 years, but these after 1 year, and these you want to keep around forever. So we run that off of the metadata in our catalog and are able to do that pretty efficiently. So storage and compute, both, one of the themes is it's about managing cost. In the case of storage, it's about lower cost storage tiers, balancing, keeping more data online versus the cost of keeping the data online. So we rarely do any kind of presentation without touching on security and compliance briefly. It's a common question. FINRA is an oversight organization. Our security has to be equivalent or better than the industry we're regulating. So here are some of the points that were used to convince our senior leadership of security in the cloud. One is we had a strict rule: when we go to the cloud, encrypt data everywhere. That's at rest, that's in transit, that's even in transit on private networks or between the nodes of one of those transient clusters. It's all encrypted. Another big point is around micro segmentation we get from security groups. So all of the network resources in our data lake and in our cloud environment actually have these security groups, which are like miniature firewalls that are pretty tightly controlled in terms of where they can talk to and over what ports. And there's also the fundamental data security that the data in S3 storage famously has 11 nines of durability. So that data in S3 is not going to disappear, extremely unlikely. And even then, we also have another copy of it in another region for our enterprise record requirements. So pretty soon after getting into the cloud, our security group started to say that the security posture could very well be better in the cloud than we had in our data center. And that's an opinion that I think is now shared pretty widely in the industry. So having tight security policies like encrypt data everywhere is one thing, but I've listened to a lot of podcasts where they deconstruct these hacks, and some of the major hacks come from the gap between policies and compliance of the teams that are building and deploying software in these environments. We have been able to take a big step forward in that. In the cloud, it's enabled by two key points. One is that everything is software managed, so the encryption policies, they're all software controlled. And those security groups, they're all software controlled. And things like the age of an image that we pick up and stand up in our container in our environment, all that is software controlled, which image we're picking up. And it's all observable because it's on a single platform. So we had some smart people put together a compliance dashboard that was just a small, started out a project for ops and security internally, but fast forward and it's it has 114 something controls that we can see at any time, and we can see how we're doing, that every team can see how they're doing with the software they deploy versus those policies. And teams I work with, we look at that every week, and we have meetings either monthly or quarterly where us and all of our peers sit in front of our VPs and look at our compliance dashboards and have a little social shaming if we're not doing as well as our peers. So that compliance dashboard has been very transformative. It's hugely effective. We're pretty good at it before, but now we're really, really on top of that. Okay, this last slide, then we'll have some Q&A. What are we doing right now with our data lake? We just completed a migration. So we have a rapid ability to get up and running in another region, fail over to another region. In the case of a regional event, this is part of our disaster recovery plan. And we've just begun a couple of really cool initiatives. One, we're making a huge investment in advanced analytics. It's going to be the next transformation for us. We hope as big as the jump we got from going to the cloud and building a data lake. We're going to significantly increase the amount of AI and ML and NLP we use in our regulatory work. I'll bring up a quote from my favorite sci-fi author, William Gibson. He said, "The future is here, it's just not equally distributed." And that, I think, is a bit of where we are with our advanced analytics. Overall, we're doing really cool stuff. There are pockets of wild success, but we're making an investment to bring the latest and greatest technology to all corners of FINRA, latest gen analytic platforms. We're going to upskill the people involved. And this is not just a data lake thing, this is FINRA wide. The big thing we're doing in the data lake right now is to centralize our data authorizations. So the picture of the data lake, we manage centrally our storage and our catalog, but all the analytics has kind of grown organically because we want people to use the best of breed and keep up with the industry. But I guess, unfortunately, the data authorizations and entitlements are kind of done in that analytics layer, which is out there and has grown organically, which is another word for saying it's inconsistent and it could be better managed centrally, we believe. So we're working with Okera, who is one of the sponsors of this event. And we have done some R&D because they have software that is intended to help us bring everything to the center around entitlements and data access controls. And it brings fine-grained access to engines like Spark and Presto, which right now don't have like column level access controls as part of the engine. So our Okera worked really well for us in the R&D, and we've started an initiative where we're going to implement this with all our data platforms. That's the next big step for us in the data lake. So I guess we wanted to leave about 10 minutes for Q&A. I don't know if we've received any questions yet, or now's the time to type in some questions in the platform.
If you don't mind, may I ask actually, may I pose some questions?
Of course.
Yes, great. You have mentioned that you mentioned a lot about hardware and getting certain flexibility and scalability through use of a cloud platform. How about the people side? You does the people side managing and developing and maintaining this 200 petabytes of a data lake? Do you need any kind of a flexibility and scalability in a people, human resource as well?
That's a fair point. So, I mean, I think historically FINRA's had what we'd refer to as platform teams. So with the goal being, obviously, you don't want to burn those people out, but at the same time, you want to try and figure out where there's some orthogonal concerns. So we haven't run into a situation where the scale of the data has necessarily meant more people. We leverage heavily the parallel capabilities of the tools that we're using, such that we're not necessarily growing the complexity of the algorithm we're using as the data scales. So thankfully, the need for people has not necessarily grown with the size of the data, though it does take as I mentioned before, it does take really strong people to deliver. But thankfully, we haven't had a problem where we've had to figure out if the cloud can provide us people.
And I think there was a transformation. It was like a great opportunity for a lot of the technologists to, work on this, work on the cloud migration. And a lot of people just really turned over their skill sets. We didn't necessarily lean heavily on external consultants. We did kind of in the beginning, but we pretty rapidly figured out that our teams were becoming, as smart as some of the external consultants, because the cloud data lake stuff especially was pretty new. So.
And I think to Nate's point, I think we did that. That was somewhat intentional. I think there's a lot of benefit to bringing in the experts early on to really help jumpstart your expertise. But your goal isn't just to deliver what you're building, but also to get your people the expertise they need to build the next thing. So I think that's been very successful.
Okay, I see we have a question about the backup and recovery strategy of the data. I think that there is, as I said, a copy of the data in another region for various purposes, but actually the durability and availability of S3 itself was such that the architects and everybody involved was able to say we did not need to, for example, implement an offsite or something tape backup or have our own copy of the data elsewhere. It's mostly fulfilled within the S3 itself, including their bucket replication features, so we can have another copy of it.
Maybe I don't know if we touched on this during the conversation, but in primarily in what we refer to as our data management S3 layer, the the data is immutable such that if by chance there's a new version of the data that you're looking to publish, you don't overwrite the data that's in place, you publish a new version of that data. So that's, I don't know if, depends on which, what kind of disaster you're trying to recover from, some of that can help mitigate that as well.
Right. That could help if there's some kind of an accidental publication, you know, in the processing pipeline or something. We never overwrite data that's been written. We always maintain it as another copy of the data.
Okay, if I may ask also another quick question. Our symposium, many of our attendees are CDOs or de facto CDOs. Now, many of them are facing this rapidly growing the size of the data they had to manage and deal with. Of course, maybe not at the level of 200 petabytes, but they're seeing significant growth of this the data that they manage. Now, what advice would you be able to share with them in terms of dealing with this rapid growth of data and the need to manage a huge amount of data that they're facing today?
I'll take a shot, and maybe Nate can fill in some. I mean, I think we touched on some of them. I think for us, regardless of the 200 petabytes or not, I do think this separation of the storage from compute is pretty important, just because I think as your data volume grows, you may want to experiment with different technologies, and you don't necessarily want to have to forklift or make a copy of the data somewhere else just so you can play with it. I think the other aspect would be is, you know, obviously I think we're always looking, you don't always necessarily know when that spike's going to come. It's not ideal to be provisioning at peak. But the other piece is you're looking for a scalable solution, and you want a solution that has those durability guarantees that you need. So I think there's probably multiple options. Obviously, S3 isn't the only one, but it can be very interesting to explore what you can do in the cloud, where you can kind of manage that data without so much the concerns of overrunning your capacity. But I also think, I'm sure with CDOs on the line, is you can't lose sight of the things that you thought were important when you understood all the data that you had at your company, which is that, you know, trying to level the playing field in terms of what people know about the data, what it is, where it came from, what does it mean, when is it appropriate to use. So you want to try and make sure that you're not totally dependent on the people, not that you don't want to keep the people you have, but you want to be able to, as new needs arise and maybe bring in new people, you want to bring them to a level playing field where they can understand the data, locate it, and so on much more quickly, as opposed to having to rely on multiple people to help them sort it out.
Yeah, I agree. I think we've had conversations. You don't need, you know, 200 petabytes of data to take advantage of key things like separation of storage compute, data management, data discoverability, the things that we've seen by this data lake approach. And I think all the cloud providers have, you know, their kind of combination of object storage and, you know, bring in various compute on top of it, like we've illustrated.
Great. Well,
All right.
thank you very much. Thank you for
Thank
sharing
you.
this very insightful experience and your experience. And I do appreciate your presentation.
Thank you.
And
Thanks.
also, I'd like to thank all the our audience, the people, those who attended this symposium, this session. We will. This is the last session in today's the agenda. So we will resume tomorrow morning. Thank you for coming, and thank you
Thank you.
very much for sharing your experience.